What up, what up, what up? Hello, grade 8. Welcome back. Today we're going to focus on What is this? 9.2 in the textbook. Patterns in a table of values. After this lesson, you will be able to identify relationships in a table of values, decide if a table of values represents a linear relation, and graph points represented by values in a table. I apologize in advance. This video might be a bit longer than what you're used to. This is a little bit complicated for some people, so I'm going to go a little bit slower and try to explain it in more detail. This unit and chapter will definitely transfer on to grade 9, and it's a big focus. So if you remember some of these tips that I give you this year, it'll help you a lot next year in grade 9. Okay. So first thing, we have this pattern right here, and we are going to separate this all and figure out the number of vertical segments. So section 1 would be right here, section 2, 3, and so on. Number of vertical segments. Vertical are just the straight lines like this. How many do we have in section 1? We have 2 of those. How many horizontal segments? 1, 2. And how many slanted segments do we have? 1, 2, 3, 4. Next one, section 2. 2 sections. How many vertical do we have? 1, 2, 3. How many horizontal? 2, 3, 4. And slanted, 1, 2, 3, 4. I was like 7, 8. We should already start to see a pattern. Typically, you can see it after 3 for sure. Gives you a better idea, but let's do 3 sections here. 3 sections. How many vertical? 1, 2, 3, 4. Can you see the pattern for vertical already? And then horizontal, 1, 2, 3, 4, 5, 6. And slanted, 1, 2, 3, 4, 5, 6. And we have 6 on the bottom. That would give us 12. So right here, we could see the pattern right away after 3. Just use a different color here. Okay, so here for vertical, we are going up by 1 every time. So this would now be 5. Horizontal, we are going up by 2. So that's going to give us 8. Slanted segments, we're going up by 4s. That's going to give us 16. All right, moving on. Okay, here's just a tip on how to find your linear relation using a table of values or plotted points that are in a straight line, just like this is right here. Okay, so every straight line can be represented by an equation, y equals mx plus b. This is important. You will see this in grade 9 a lot. The coordinates of every point on the line will solve the equation if you substitute in the equation for x and the y values. The slope, m, of this line is its steepness or slant can be calculated using this right here. So this m equals the change in the y value divided by the change in the x value. So that is important information to remember. And this can also be shown change. I'll just give me a second here, sorry. this can also be shown like this. M is equal to change in y, that triangle means change, over the change in x. And you'll see me use this short form. Instead of writing change in y value, I'll use the triangle y to show that same, Okay, the equation of any straight line, called a linear equation, can be written as y equals mx plus b, where m is the slope of the line and b is the y-intercept. So we'll get another highlighter color. B is the y-intercept. And we will change to a pen. Give me a second, sorry. What's going on here? Pen. Green. Perfect. Okay. And then y-intercept of the line is the value of y at point where the line crosses the y-axis. So in that point here, the y-intercept is where the line crosses the y-axis. So that right there would be the y-intercept. Okay. So here, looking at these points, we are going to find y equals mx plus b. So remembering, m is the change in y over the change in x plus b, which is the y-intercept. So looking at this, the change in y, let's make a table here. X, y. First point, x is 0, y is 1. Second point, x is 1, y is 3. And our last point is x is 2, y is 5. Okay, so here. Our change in y, we are going up by 2. So that's going to be our change in y. Over our change in x, which is just 1. X stays, plus b, which is our y-intercept. And our y-intercept is when x is 0, what is y? In this case, it's going to be 1. Okay, now we can simplify this right here. What's 2 divided by 1? Well, that's just 2. X plus 1. So this is our linear relation. Now it's our linear equation. We can check to see if this equation is correct by substituting in our values from our table or from our graph. So I'm going to do that, show that substitution here, and I'm going to just do a check. Check. So y equals 2x plus 1. This is the equation that we found. To substitute look at our chart. Let's substitute in right away. Let's just start with this, 0 plus 1, and our y value in this case is 1. Okay, drop everything down. 2 times 0, 0, plus 1, 1. Keep our equal sign. What's 0 plus 1? 1. Does 1 equal 1? Check. We know that this linear equation is correct. Okay, I know that might be a little bit complicated. I'm going to do a couple more examples. Hopefully that becomes clearer as we move on. All right. So here, we have another table of values. We want to find the linear equation using this table, and then the expression. Okay, so step 1. We'll just rewrite this so that we recall y is equal to m, which is the change in y over the change in x, times x, that stays, plus b, which is the y-intercept. Okay, you don't have to write this step down when you're showing your work. I'm just writing it down so that we can reference it as we go. Okay, so how do we find the change in y over the change in x? Well, first thing, this is always going to be x, which is first. This is going to be y. Change in y. We are going up by 3 using our table. So the change in y is 3. Change in x, going up by 1. And then we can write the rest of our equation. Our y-intercept, that means when x is 0, what is y? 0. All right, let's finish writing the rest. Y equals 3 divided by 1 is just 3. X stays, plus 0. If you're adding 0, do you really have to write it? No. Okay, so this is our linear equation. Then we're going to do a check. So we're going to substitute in our x and y values using our new linear equation that we just found to see if the left side is equal to the right side. So we have y equals 3x. We'll pick any values off of this table, so we'll just do, let's pick the last one. So our y value is 12. 3 times substitute in our x, which is 4. 12 is equal to 3 times 4, which is 12. Is 12 equal to 12? Yes. Then we know that is our linear relation. And if we plot those points right here, 0, 0, 1, 3, and so on, that creates a straight line, which is a linear equation. If we can recall linear equation, equation means there is an equal sign. An expression means there is, pausing for answer, yes, no equal sign. So what would the expression be? Simply 3x. Okay. Moving on. Find the linear relation of the table using y equals mx plus b. This is very similar, but just instead of us going only up by 1 with the x values, we're going up by 4. So I'd like you to pause the video and give this a try on your own. If you have no clue, that's fine. You can continue on and try watching the solution, but I suggest you pause and give it a try. All right, so again, oops, sorry. We got y is equal to the change in y over the change in x times x plus our y-intercept. So looking at this, change in y is 2 to 10, that's going up by 8. Up by 8, so on. So we know that's going to be 8 over change in x. It's going up by 4, up by 4, and up by 4. X stays plus our y-intercept. Our y-intercept is when x is 0. What does that mean? So that's going to be plus 2. And now we can simplify this. So y, 8 divided by 4 is 2. X stays plus 2. So this right here is our linear equation. If we were going to show this as a relation, that would just be 2x plus 2. That is our linear relation because there is no equal sign. Lastly, let's just do a check here to see if that is correct. Check. Y equals 2x plus 2. Let's pick a value to substitute in. Let's just use the second one here. Our y value is 10. 2, substitute in our x value, which is 4 in this case, plus 2. Drop down what we know, simplify. 2 times 4 is 8 plus 2. 10 is equal to 8 plus 2, 10. Is 10 equal to 10? Check. All right, hopefully that's starting to become more clear for you guys. Please, please, please ask me questions if you have any during our office hours on Wednesday and Friday. Okay, here is another example. We can see right away we have our x values and our y values, and we've plotted our points, 2, 3, 4, and so on. This does create a linear relation. So I want you, using this information, I want you to find your linear relation. Find the linear relation. I want you to pause the video, give it a try, find your linear relation. Once you're done, press play. Okay, so again, to find a linear equation or relation, we use the formula y equals mx plus b. M is equal to the change in y over change in x times x plus b. Step 1, what's the change in y? We can see that here. 3 to 7, it's going up by 4. 7 to 11, 4, and so on. So we know that's going to be 4. The change in x is 2 to 4. Well, that's going up by 2's. X stays. B is the x, the y-intercept when x is 0. It's not given to us here, but if we were to have a spot here for in our table, so let's just move this up a little bit. If I left a spot for that information here, I want to know when x is 0, what is y? Well, we know that we're going up by 2 here, and we know we're going up by 4 here. So if we're going to add 4 this way, if we're going backwards, what are we going to do? We're going to take away 4. So what's 3 minus 4? -1. Okay. So that will be, we're going to add -1. Now let's rewrite this using simplification. 4 divided by 2, 2. X stays. We're going to add -1. So that's just like saying -1. So that is our linear relation. Let's do a check. Oops, sorry. Check. Y equals 2x minus 1. Let's just start. Let's start with 0. So y in this case is -1. 2 times, substitute on our x value, which is 0, minus 1. Drop that down. 2 times 0 is 0, minus 1. -1 is equal to -1. Check. Okay. This right here, we have a table of values, and it is graphed. Plotted all of our points, so these coordinates, and so on. After plotting these points, you can see right away the relation is not linear. It's not linear because this goes up by 3, this goes up by 3, this goes up by 1, so that's not going to work right off the bat. So we know that this is not linear, therefore we cannot create a linear relation. Show you know. Determine whether each table represents a linear relation. Explain how you know. Check each answer by graphing the ordered pairs. Okay, so here I'm not going to get you to graph the ordered pairs. I'm not going to do it either. I think we understand how to graph, how to plot points. But just looking at these tables, and can we see a pattern? And if there is a pattern, is there a linear relation? So pause the video, see if you can determine if each table represents a linear relation. And write the linear relation down. Table 1. This is going up by 3, up by 3. This is going up by 9, and this is going up by 9. Right off the bat, our A value is consistently going up by 3. Our B value is consistently going up by 9. Is this a linear relation? Yes, it is linear. And then using this information, if we wanted, we can create our linear relation using the change in y over the change x plus b. So that's going to be the change in y, in this case xy, 9 divided by the change in x, which is 3 times x plus b. So if we had 0, what would our x be? Well, we're going up by 3s, so going backwards, we got to subtract 3 from that, which is going to be -2. Then we can simplify that. 9 divided by 3 is 3x. So that would be our linear relation, and let's just do a quick check here. Because why not? Y equals 3x minus 2. Let's just pick 1, 3. Substitute in our x value. 1 minus 2. I'm running out of space here, so I'll just do that. 1 is equal to 3 times 1 is 3 minus 2, 1 equal to 1. Check. Okay, this next one. We're going up by 1, 1, 1. This is going up by 1, 2. Oh, right away. Is that table going to represent a linear relation? No. Why not? Because we are not going up consistently by the same amount in the table. So no, it is not linear. All right. Okay, Photo World charges $3 for the first enlargement and $2 for each additional enlargement. Using this table, this is going to be x, this is going to be y. Can you find the linear equation or the linear relation for this? Pause the video, give it a try. Y equals mx plus b. Y is equal to m, which is the change in y over the change in x times x plus b. Step 1, change in x. That's going up by 1. Change in y. Going up by 2. Y is equal to change in y, 2, over the change in x, which is 1. X stays. B is our y-intercept. So when x is 0, what is y going to be? Again, for our y, we're going up by 2s. So if we're going backwards, that means we have to take away 2, which gives us 1. Simplify this. 2 divided by 1 is 2x plus 1. And let's do a check. Y equals 2x plus 1. Show our substitution. Let's pick this first one. Our y value is 3. 2, substitute on our x value, which is 1 plus 1. 3 equals 2 times 1 is 2 plus 1. 3 is equal to 2 plus 1, 3. Boom. We got it. Hopefully this is starting to become more clear for you guys as we go. I know that this can be a pretty complicated section. All it really takes is remembering what y equals mx plus b is, and if you can do that, then it should be easier for you to substitute in what you know. As long as you remember what y equals mx plus b stands for, that could be very helpful for you. Okay. This last one here. Sky sells magazine subscriptions. She receives $20 for every 5 subscriptions she sells. The table shows the relationship between the number of subscriptions she sells and the pay she receives. Copy and complete the table. Is this a linear relation? How can you tell? What is an expression for Sky's pay in relation to the number of subscriptions she sells? How many does Sky receive for selling 40 subscriptions? Okay, so this is a show you know. I want you to give this a try. Once you're done, press play. If you are completely understanding everything, you can skip ahead to the one last thing provided on today's assignment. Submit that to me by 3 p.m. and you're good to go for today. All right. Step 1. Don't need to copy the table, but I'll complete it. This is going up by 20s. 60 plus 20, 80. 80 plus 20, 100. Okay. Is this a linear relation? How can you tell? Well, first off, our y value, or p in this case, is going up by 20 every time. And our x value is going up by 5 every time. So that's consistent. Is this a linear relation, excuse me? Yes. And I'm not going to write this, but because we have a consistent pattern, our x value is going up by 5s every time, and our y value is going up by 20 every time. What is an expression for Sky's pay in relation to the number of subscriptions she sells? So again, mx plus b. So that would be change in y over change in x, x plus b. Change in y is 20. Change in x is 5. X stays plus our y-intercept. So when x is 0, what is y? 0. Simplify that. 20 divided by 5 is 4. X, do we need to add that 0? No. So that is our expression. How much does Sky receive for selling 40 subscriptions? So we have 4x, or because we're not using x and y in this case, this could be 4n, because this is using n for x. Either one works. Okay, so now how much does Sky receive for selling 40 subscriptions? Well, we can just use our relation that we found. So 4n. And let n equal the number of subscriptions. Okay, so we have 4n. So let's substitute in 40 subscriptions. 4 times 40 is 160. And that, we'll write a little sentence here. Sky receives $160 for selling 40 subscriptions. All right, that is everything for this section. These are the key ideas. You can look through them if you would like. And that is it. Today, after you're done watching this video, I want you to do the the one last thing provided. Submit that to me by 3 p.m. And that's it for today. Tomorrow, I will post some practice questions. Wednesday, I will have an optional Google Meet for office hours where you are welcome to ask any questions you may have. And Thursday will be some more practice stuff. And Friday, I'll have another optional Google Meet. It'll be Fun Friday. Optional Google Meet. Ask any questions you may have. I stress, please ask questions if you have them. That's what office hours are for. I know this can be a little bit difficult for some people, so please, please, please ask questions if you have. All right. Have a good day. Bye.